Dear student, this is Professor Shailesh Devdar Janmantu from Department of Computer Application, GS College of Commerce, Wardha. And today we discuss about the fundamentals of computer, and today's topic is memory and storage system. Memory and storage system. By default, when we talk about the memory, we think that the computer has a memory, just like us. Human has a memory power to understand, to recognize, or to imagine. Computer system also has a memory. That is called main memory. Or we have two types of memory in computer. That is preliminary memory or primary memory and secondary memory. We discussed the primary memory and secondary memory in block diagram of computer. So the memory is used in computer system is to store the data permanently or non-permanently or current. Means we can store the data into memory of computer permanently or volatility. Memory had some portions to store different type of data, instructions and result temporarily. Means main memory of computer system can allocate or can store the memory or the data or the instructions or the result of process on temporary basis. Okay. Memory representation in computer system, by default, when we talk about the computer system, first memory or primary memory is our RAM, random access memory. A memory of computer is a place where we can store text, files, instructions, intermediate result, stored or executing program. The total memory is organized into a number of bytes, and each byte is again divided into 8 bits. Means we can say that particularly the data will be stored into a computer system in a byte, and that byte can be converted or calculated on the basis of bits. So our information or data always stored in a bits, that is called 0 and 1. It is also called the binary digit, or we can store the data according to the binary digit into the memory system, and that number also called as the address of a memory. These all things or these all binary numbers are stored on the addresses, and that addresses can be identified by byte address, and this byte address or a 1 byte address contain 8 bits. If we consider a diagram just like a memory diagram, a memory which is available in a computer system, each memory is slotted or divided into byte. And each byte has an individual address, just like 2001, 2002, 2003, 2004, 2005, 2006. Let's consider these are the numbers which represent a particular memory byte, and each byte is again divided into 8 bits. 1, 2, 3, 4, 5, 6, 7 and 8. And all the data which is available in our computer system, the data will be stored onto these bits in the form of 0 and 1, 0, 0, 1, 0. Means each byte is considered byte. This is called bits. Means 8 bits equals to 1 byte, and each byte has a specific address into the memory. So our data will be stored, or our memory will be available in this format into our computer system. So likewise all the data will be stored into our computer system. So how a number can be stored in our computer? Just like if we store a number, a number representation in a memory. When we say, just like an integer x equals to 95. This is a decimal number and it can be stored into our computer system. But when we talk about the computer system cannot understand the high level language. The 95 is a decimal number which can be understood by the human, but 95 cannot be understood by the computer system. Therefore, computer system only know the binary digits or machine level language. So, this particular 95 number should be converted into the binary digit. So, to convert the binary digit or equal binary digit, we should divide this. We should divide this by 2. Just like remaining 1. Again divided by 2. Remaining 1. Again divided by 2, remaining 1, again divided by 2, again till we get a 0. So from the top, bottom to up, 0, 0, 1, 1, 1, 1, 1. This way we can convert the decimal number into equivalent binary number. So the 95 can be assigned into a byte, and this byte has a 8 bit. So this number should be converted into 8. So write 1, 1, 1, 1, 1, 0, 0, 0. So this way the 95 number or a decimal number or any type of number which are stored into a computer system, not in the format of decimal number, means 95, it should be converted into the binary one, and that binary digit can be represented like a 0, 0, 0, 5 times 1, likewise. So 95 can be represented in a memory likewise. Okay, so this way a number can be represented into a computer system or stored into a computer system. Same way, when we say about the numbers can be converted into decimal to binary. This decimal number can be converted into binary and it will represent or stored into the memory. Okay. Now same way the character representation. Character representation into the memory. When we talk about character, just like A, B, C, D, these are the characters. We have 26 characters. Rather than we have special symbols or any other symbols which are available on our keyboard. These all are characters. Even if numbers also called as a character. And each character can be represented on our keyboard have its equal ASCII value. Equal ASCII value. And ASCII value is nothing but a number representation of a key which is available on our keyboard. We have different type of keyboards and according to keyboard different type of keys are available. So when we talk about the keys, that is A to Z, small a to Z, some characters or symbols are available on keyboard. All these characters can be represent a unique number, and that unique number is called as a ASCII number or decimal number called as a ASCII number. ASCII stands for American Standard Code for Information Interchange. Information interchange means that number can be represent a specific character. So when we press any key, that time we press a key. Consider we press A key. A key has a specific or unique code number or ASCII number, that is 65. So when we press a key or a key, that time it will represent 65, but 65 is a number, a decimal number, and that decimal number also doesn't store on our memory. So this 65 again converted into binary number. Likewise, just like we convert a decimal number into binary, same way again 65 divided by 2 remaining 1, 32 divided by 2 remaining 0, 16 divided by 2 remaining 0, 8 divided by 2 remaining 0, 4 divided by 2 remaining 0, 2 divided by 2 remaining 0, 1 divided by 2 remaining 1. From bottom to up, so we have 65 equivalent the binary number, that is 10000001. Means when we press a key, that time it will convert it into binary decimal number. That decimal number is called as a ASCII number. That ASCII number can be converted into binary one, and this binary digit will be represented or stored onto our memory according to bits. Means everything can be converted into bits. 8 bits system or 8 bit equals to 1 byte. Means when we store a character, a number, we need a memory space, and and that memory space is identified by the byte, and byte can be converted or byte can be calculated according to the bits, and 8 bits equals to 1 byte. These some abbreviations which are used to memory representation. So we talk about the abbreviations. Unit, abbreviation, and the storage space. The smallest unit is called as a bit. The smallest unit is called as a bit, and it abbreviated by B. The storage is single. Storage is a single digit. That is 0 or 1. Means it can hold only 0 or 1. Second one is nibble. Second one is nibble. It doesn't have any abbreviation. Nibbles means 4 bit. 4 bits. When our computer system is 4-bit system, means the data will be converted into the 4-bit. That time it or the nibble is used. Third one is byte. We already discussed about the byte. It is also abbreviated as B, and 1 byte equals to 8 bit. 1 byte equals to 8 bits. After byte we have kilobyte. We have kilobytes, abbreviated as KB. And 1 kilobyte equals to 1024 bytes. 1024 bytes. After that, next memory representation is megabyte. Megabytes, called MB. Called MB. 1024 KB equals to 1 MB. 1024 KB equals to 1 MB. After MB we have gigabyte. We have gigabytes, called as GB. Normally we use GB for our mobile phones. The memory is in the form of GB, from 32 GB, 64 GB, 120 GB, 16 GB. These are GB, gigabyte, and 1024 MB equals to 1 GB or gigabyte. After gigabyte, terabyte, called TB. Called TB. Normally this TB is used for external memory. We have 1 TB external hard disk, 2 TB external hard disk, or in our computer system laptop 1 TB hard disk laptop. This TB is called as a terabyte, and 1024 GB equals to 1 TB. Equals to 1 TB. Next one, petabyte. We heard about bit, nibble, byte, kilobyte, megabyte, gigabyte, terabyte. Now we use the terabytes. But after terabytes we have another some abbreviations or storage representations, that is called petabytes. It is never be used in a common. When we have much larger memory space, that time we use the petabyte. So petabytes called PB. and 1024 TB equals to 1 PB or petabyte. Next one, exabyte called EB. 1024 PB equals to 1 AB. After that, zettabyte called abbreviated as ZB. 1024 EB equals to 1 ZB or zettabyte. And last one, that is most expensive and storage capacity, is called petabyte, called YB. 1024 ZB equals to 1 petabytes or 1 YB. So these are the memory representation into our computer system. How a number can be represented into a computer system, how a character can be converted, and what type of memory available in our computer system, just like bit, a smallest unit of memory, nibble, 4 bit equals to nibble, byte, 8 bit equals to 1 byte, and another some ones just like kilobyte, megabyte, GB, terabyte, petabyte, exabyte, zettabyte and yettabyte. These are the memory representations in our daily life or in our computer system. So memory is nothing but a chip which is mounted on our computer system's motherboard. It can be a volatile or it can be a permanent. Primary memory are always RAM, which is volatile memory, which can be erase all the things after the switch off. So all these memories are available in our computer system, and how the numbers and the characters can be represented in our computer system, and the abbreviations which are used for representing the memory which are related with computer. Okay, thank you.